Welcome to the third section of our course. In this section, we'll be working on CNN for computer vision and deep learning. In the very first video of this section, we'll introduce convolutional neural networks, CNNs. In this video, we'll get to know what convolutional neural networks are. We'll also get to know what convolutional layer is, and what's the purpose of pooling layer and dense layer. In simplest of terms, a convolutional neural network is a learning algorithm which can take in an input image, assign line number weights and biases to various portions in the image, and then classifies the entire or a portion of the image. The whole convolutional neural network is made up of different layers: convolutional layer, pooling layer, dense layer, and so on. So let's talk about convolutional layer. A convolutional layer is the core building block of a convolutional network that does most of the computational heavy lifting. Like other layers, a convolutional layer receives inputs, transforms it, and passes it to the next layer. Convolutional layer has filters, and each filter detects different aspects of the image. Some filters may detect lines, edges, or simple shapes. In deeper layers, filters can even detect sophisticated objects such as full cat faces, etc. Pooling layer. We usually insert a pooling layer in between successive convolutional layers in a CNN architecture. Its function is to reduce the spatial size of the image to reduce the number of parameters and computations in the network, and hence to also control overfitting. Pooling layers are generally used to reduce the size of the input and hence speed of the computation. If you see the image below, on the left side you see a bigger image, and on the right side you see a smaller image after pooling operation. The bigger image is partitioned into 4 different sections based on the pooling filter, which is 2 by 2 here. And in each region, say the red region, only the maximum pixel values are kept and all the others are discarded. Same goes for green, yellow, and blue. The pixel with the highest intensity is kept and all the others are discarded. Hence the image is reduced to a smaller image without losing the important features. Dense layer. Neurons in a fully connected layer have full connections to all activations in the previous layers, as seen in the regular neural networks. Their activations can hence be computed with a matrix multiplication followed by a bias offset. So now you have got the basic understanding of convolutional neural network, and as we proceed towards this section, your understanding will get clearer, and we'll be loading the dataset for that and split the dataset into training and testing.